Chapter 3 is about software. It has two parts to it, and they basically talk about the operating system in the first half, and then in the second half, it talks about the different kinds of application software. So we've been talking a lot in chapters 1 and 2 about the hardware, the physical components of the computer. In chapter 3, we start to talk about those instructions that the computer needs in order to be able to do the things that you want it to do. So, the first half of chapter 3 basically goes through what the operating system is and how it helps to manage all the different things that your computer can do. So we're going to summarize the operating system's purpose and then describe how data is used by your computer. And then we'll look at some of the different operating systems that are used and how Windows is used specifically. So, there are several different types of operating systems. The most common one is a multi-user or multitasking operating system, which is basically what you have on most of your computers. Windows allows you to set up accounts for multiple users so that they can use the program simultaneously. And it can operate several programs at the same time. Other kinds of operating systems that are not as common are, first, a real-time operating system, which is basically a very small operating system, and it's designed to be able to respond quickly. This is the kind of operating system that you might see on maybe like an ATM machine or a debit card reader, where it's running a device that doesn't do a lot of stuff, but it needs to do things quickly. A single-user, single-tasking operating system is what would have normally been on older smartphones and cell phones, where you basically have one person who's using it and they only do one thing at a time. So for example, if you were on the internet, you would probably have to get off to be able to answer a phone call. Cell phones now, the iPhones and Android devices, most of those are multitasking operating systems designed for a single user. So you can't create multiple different accounts on your cell phone where you can switch backgrounds and you have to log in. But they can do more than one thing at a time. So on my phone, for example, I have a Samsung, which is using an Android operating system. I can switch back and forth between my phone and my calendar, so I can be talking to someone on the phone and check my calendar at the same time. I don't have to hang up the call to be able to check the calendar. The operating system does four basic things. The first thing is that it supports programs. So it's sort of like an office manager. When you start a program, Windows, which is the operating system on most PCs, tells the other programs what to do. Operating systems are also designed to be able to share information between other programs so that when you copy something, for example, in Microsoft Word, you can paste it into an Excel spreadsheet or onto a PowerPoint slide. The operating system also houses and manages all the sets of instructions that allow the different pieces of hardware to work. So when you plug your printer into your computer, for example, the operating system recognizes that something new has been plugged in, and it searches for the instructions that the printer needs to work properly. And finally, the operating system manages those device drivers. So it basically has all of the different instructions saved for all the different kinds of devices that you might plug in to your computer and work with. The first big function we just looked at is that it supports programs. So it essentially is like the Office Manager. It prioritizes what you're doing and determines what kind of processing power is put into each of those different applications. And so if you open Microsoft Word, for example, and you're typing in a document, and then all of a sudden you realize you have to go and find something on the internet, the operating system is what sort of manages what's happening at the time when you're on the computer and decides what kinds of processing power goes into each of those applications. So when you switch from your Microsoft Word program to, say, Internet Explorer or Google Chrome, the operating system manages what you see on your screen and what the processor is doing at any point in time. With Windows, you can share data. So you can copy information from one place and temporarily store it onto the clipboard and then be able to paste it somewhere else later on. And so you can use these commands in almost any program. You can copy something from the internet, for example, and paste it into a Word document. You can paste a picture into a PowerPoint slide if you've copied it from another website. You can use the clipboard between programs, so it doesn't have to be all within Microsoft Word. So you are not limited from copying in Microsoft Word to pasting in Microsoft Word. You can go back and forth between programs. And that's because of a feature called OLE, or Object Linking and Embedding. So the instructions that go along with whatever you cut or copied are saved with the object when it's placed wherever you're going to paste it. Another thing that your operating system does is that it manages the hardware. It sort of acts as that middleman between your computer and those devices. So if you go and print something, for example, when you hit the print command in Microsoft Word, the operating system sends a signal, what's called an interrupt request, so that the system connects to the printer. And then finally, along with managing that hardware, it also is it houses all the drivers, which are the instructions that allow those devices that you connect to your computer to run properly. So a lot of hardware now is called plug and play, which means that if I plug a printer into my computer is going to recognize that I plugged something in, and it has a set of already created instructions for how to operate that printer. Prior to these plug-and-play devices, you used to have to install the driver. So when you would buy an external printer, for example, you would have to install it. So you would put a CD into your computer and then run the setup and then plug your printer into your computer, and the CD had all the instructions for your computer to know what to do when that printer was connected. Most devices now don't require that extra CD, so you just plug your device into your computer. Those instructions are found somewhere, and the computer then is able to operate that device. In computer language, information is coded. And one of the ways that you have to code the computer data is so that we can recognize it on the screen, because the computer basically reads zeros and ones, or combinations of zeros and ones. In order for us to be able to make sense of those zeros and ones, it has to be in letters and numbers that we can understand. And so binary is the computer's number system. That's the combinations of zeros and ones. In order for us to read it, we have a variety of text codes which take those zeros and ones and combinations of zeros and ones and put them into letters and numbers that we can understand. ASCII, or ASCII, is one of those, and that's the most basic computer code for language. Basically, there are combinations of zeros and ones in sets of 8, and they basically represent the alphabet characters and then the numbers from 0 to 12. Extended ASCII basically takes those same combinations and allows them to represent a much wider variety of numbers. And then because we have people with different languages using computers, there was a need to develop a worldwide standard, and they can use a variety of combinations of zeros and ones to represent other letters, numbers, and symbols that are not just the American alphabet. Not a whole lot to have to memorize about this particular information, but just know that the computer doesn't read information the same way humans do. The computers basically intake zeros and ones, and then they have to be translated into things that humans can understand in order to make sense of them. When you put information into the computer, either by typing on your keyboard or clicking with your mouse, that data has to be transferred to the different hardware components so that the computer knows what to do. And a bus is that path where data is moved around. And there are different kinds of bus plugins, and basically they depend upon the kind of device that you're using and how much data can be transmitted at one time. So a parallel bus basically sends information across multiple wires. So it's basically zeros and ones flowing through these wires that are usually made of some kind of metal and going into your computer. A serial bus basically is sending 1, 0, or 1 at a time, but in a series of in an ordered series. An internal bus directly connects to the memory, and then an external bus allows you to connect external devices to the CPU. And an example of that would be a USB port. The zeros and ones have to travel through via electrical pulses for the most part, and then the computer interprets those electrical pulses as combinations of zeros and ones. Some of the different kinds of external buses that you might see are these here. The IEEE 1394 is also called a FireWire, and it's usually used for video and audio. They have more plugins or more connectors, so because audio and video files are normally really large, this type of bus allows you to transfer more information at a time, and they're more common on Macs than on PCs. A PCI bus is basically a hub of some sort, and it allows you to connect a variety of different hardware devices into the computer at one time. The replacement or the more modern version of that is a PCI Express. The SATA is the current standard for how you connect a hard drive to your computer, and so that's going to be something that you can use to connect an external hard drive or an internal hard drive. And then the USB is the one I mentioned earlier, and that's the most common one. Most hardware devices now have a USB connector that they use to connect it to the computer, and you just plug it in to the side or the front of your machine. Inside your computer, in order for all of these things to happen, in order for the software to run properly, it requires memory. And my analogy back when we were talking about the different kinds of pieces inside of the motherboard or on top of the motherboard inside the system unit, memory is the equivalent of your counter space in your kitchen. So the more counter space you have, the more efficient you can be when you're cooking. That's what memory does for your computer. And so the more memory that you have, the faster your software can run. Cache is an example of a fast type of memory that allows it to store some things that your computer uses all the time so that it doesn't have to go back into permanent storage when you want to do something. And so there's two basic components when your computer starts to process information. So you input something, and then the first half of it is the control unit. And this is where the computer then takes whatever you did, either you typed or you clicked, and it interprets those electrical pulses of zeros and ones. So it goes back to its instructions and it says, what is this person asking me to do via these instructions that it's given me? And once it finds the instructions that match what you've asked it to do, then it actually goes on with the processing, and that happens in the arithmetic logic unit. So you basically tell the computer to do something, and then it processes that information, and it gives you something back. And that's what happens in the machine cycle. So you type something, you click something, the computer goes and looks for it, that's in the fetching step, and then they decode whatever the instructions are in order to figure out what you want it to do. In the second part, it's the executing that happens, and it carries out whatever the instructions say, and then it stores the results if they need to be stored or they are output on your monitor or printed out on a piece of paper. Information that goes into your computer or data is measured in different units. A bit is 1, 0, or 1, 1. And the number of bits the operating system uses is the bit size. Every byte has its own unique identifier called an address. So whenever it has to access instructions in the random access memory, it could go to find those instructions. If the operating system was designed to be able to work with a variety of programs, we call it backward compatible. And that basically allows you to upgrade your operating system as upgrades are made so that you don't have to keep updating all the other software on your computer. And then finally, the emulator is a program that's designed to recreate the exact environment of an older program. So just to give you an example, if you are using Microsoft Word 2013, but you're very comfortable with 2011, you can use an emulator program to be able to make 2013 look like the 2011 version. For the most part, you wouldn't want to do that because 2013, Office 2013 has many more features, but it'll allow you to create something that's familiar on your screen. Some common operating systems, Windows is what's on most of the PCs or IBM compatible computers. So all of the laptops and all of the desktops in the lab are Windows machines. Macs have become much more popular because of their size, how they look, and so Mac OS has become another very popular operating system. For computer programmers and real techie people, Linux is another option that allows you to be a lot more flexible because you can actually do a lot with the coding. And then some of the others that you might see on some different kinds of devices. So on mobile devices, Android and iOS for iPhones and iPads are very popular or common. And then Chromebooks have their own operating system called Chrome OS. The other thing that the operating system does is it allows you to organize the disk storage. So when you go and you save something, the first thing that you have to do is to format a disk. Most DVDs and flash drives come already formatted, so you don't have to do that. But sometimes when you plug a device into your computer, it'll get a message that says, do you want to format? And basically what it's doing is it's setting up the drive to be able to organize and store data. So the different things that happen during formatting is, one, it forms tracks. So if you're using, especially on a hard drive or a CD, as you format it, different rings are created where data will be stored. And then it divides that into sectors, and that allows you to be able to search for things on that disk later on. Once you have a disk that's formatted, now you can start to save information, and in order to be able to find it later, there has to be some sort of system for how to look for it. And so a file system is a method for being able to put things onto the disk and find it later. When you create the disk or when you format it, 4 things happen. One is it creates a boot sector, so it tells the computer what to do when the computer starts. The second thing that happens is it creates a file allocation table, and that is basically kind of like an address book. It keeps track of all the different sectors on the disk, and that way it'll be able to tell you where things are, and you can keep track of where they are for later. A root folder is created, then that tells you where all the information from other files are on the disk. And so these 3 parts take up some space on whatever your storage device is. And then eventually the rest of the disk can get used to store data. Different types of file systems that you can use. The NTFS allows for a little bit better security. This is just a name that is given when you create a disk and start to format it. So these are not things you necessarily have to memorize very closely, but just be aware that when your computer formats a disk and you want to start saving stuff, there's different methods for organizing. Sort of like saying, I'm going to put files in alphabetical order, or I'm going to put them in order by date. Whatever method I choose helps me remember where I can find stuff later on. WebDAV, or web-based distributed authoring and versioning, is another system and allows you to store things online. So when you store stuff on your Google Drive, or if you have a cloud, if you have a Mac, that's the system that those different operating systems use to be able to manage your files. And then you can create a shortcut to be able to find those files later. So on your desktop, when you first turn on your computer, you have all those pictures. Those pictures, when you click on them, directly link you to wherever that program is housed on your hard drive. The operating system that you use also has some utilities that are connected, which help you to make your computer run more efficiently and gives you some tools that you can use. So on our Windows computers, if you click the Start button, you have a folder that actually says Utilities. Some of the kinds of things that you can find with your operating system are backup utilities. So I don't do this as often as I should, but you'll hear people say you should back up your files. The backups allow you to make sure that if your computer ever crashes, you can save what's there. Anti-malware programs, when you surf the internet, sometimes malware gets downloaded onto your machine without you knowing. Anti-malware basically helps you get rid of those files. A firewall is a safety security type of utility, and it manages what access people have to your computer. And then finally, a screensaver allows you to save some power and save the life of your monitor. So these are all things that you can set up using the utilities that your operating system comes with. So that's all about operating systems. The second half of chapter 3 goes into the different kinds of applications. And the kinds of applications you can use are really dependent on what you need to use your computer for. So a lot of this half is going to be mostly examples. It's going to go over the different ways that you can install or put software on your computer. Some of the kinds of programs that we use in our class and that get used most often, and then how to use graphics. So there's a few different ways that you can buy software. Commercial software is basically programs that you have to pay for. A lot of programs now, you don't actually go and buy a disc anymore. You can go online and pay for it, and then the software gets downloaded. Freeware is software that you can download for free. Usually if software companies are testing something, they allow you to use it for free so that you can give them feedback. There's also a lot of free programs out there that people just want to get credit for. Open source software is normally also free, but the main difference is that with open source software, the publisher or the writer of the software wants you to have an opportunity to code the program and make changes to how it works. So when you download open source software, you have the option of, if you know how to do computer coding, you can actually modify or change how the software works by adding to the code. And then more popular now, because the internet is available everywhere, are web-based applications. So Google Docs is an example of a web-based application. You log in to your Google Drive through the internet, through your Gmail, and online you're actually doing the typing and the creating of your slideshows. The problem with web-based applications are that you have to be connected to the internet. These are some of the different ways that you can buy commercial software. Programs can be sold as standalone, which means you only buy one program, like Microsoft Word. If I went into the Microsoft website, I can download and pay for just Microsoft Word. But the more common way to buy programs like that are in a software suite, where you can buy a variety of programs that work together. The benefit is that when I download Microsoft Office, all of the different clip art and tools and themes don't download multiple times. So I don't have a huge amount of my storage space occupied by those individual standalone programs, because you could just as easily go and download Word and then PowerPoint and then Excel and then Access, and then they're each taking up their own space. A lot of times software suites are also cheaper, so if I buy Microsoft Office, I will pay less than if I bought each of those programs individually. The last way that you can download or buy software is as shareware. Most of these are the kinds of programs you can use for free trial and then you pay later. So like when you go and you download a program and it says you have 7 days to try it before you have to buy, that's sort of what we did when we downloaded the SimNet at the beginning of class. Everybody had 21 days to use it before they had to decide if they wanted to buy it. Open source software is free. We talked about this a little while ago, and you can download it for free and you can make changes to it if you know how to. Those are the different kinds of software that you can find online. And then web-based applications are the ones that we talked about, like Google Docs. There's lots of web-based applications that you don't have to actually install anything on your computer. You work through them on the internet. SimNet is an example of that. You go online, you log into your SimNet account, you do the homework, and you do the projects. It doesn't require you to save anything on your machine, but it does require you to connect to the internet, and a lot of times stuff gets saved online in your account if it's one of those types of programs, so you have to log in. To install software, most of the time if it's from the internet, you download it onto your machine, and the computer creates a registry or a location to tell the operating system where that software is going to be housed, so that whenever you click on, say, Microsoft Word, for example, it knows where to go to find the instructions for how to tell Microsoft Word to operate. And you basically then take the computer through the installation process. So the first step is to have the program saved on your computer, and then the computer basically opens the instructions and starts to install it onto your machine, so that when you click on the icon for Microsoft Word, the program opens and starts to work. Productivity software is what we cover in this class. It's all those things that you can use to make your job or your schoolwork or any other kinds of tasks easier. So anything that you use to make your job easier would be considered productivity software. Word processing programs like Microsoft Word or Google Docs, spreadsheet programs like Excel, presentation programs like PowerPoint, and then database management programs like Access are all considered productivity software. You can also use a personal information manager like Microsoft Outlook allows you to create a profile and saves all of your important contacts. Word processing programs allow you to create documents. I'm not going to spend a huge amount of time on this particular slide, but these are some of the features of a word processing program. Since we are pretty familiar with Word, a lot of this should sound similar. It allows you to format the document to look the way you want it to look. So here's some vocabulary related to word processing. A spreadsheet program is what we are using now with Excel. It allows you to enter and manipulate numbers. So the different terminology connected to Excel are here. And these are some of the other things that you need to know. We talked about a lot of this as we were going into our introduction into Excel. Microsoft PowerPoint is a presentation program, so it's meant to help you create a visual aid that will normally go on a screen or on a big projector for an audience to look at. And here's an example of what it might look like if you were presenting. Some of the things to think about when you're using PowerPoint is that you also need to have some other hardware to be able to project your slideshow for the audience. And then finally, Access is a database management program. It allows you to record and store information, and then you can actually search for specific data when you need it. So as we get into Access, some of these terms will become more familiar to you. Microsoft Outlook and any of your mail programs where you can store contact information are all examples of personal information management software. Usually this is something that you would have on your cell phone to help you manage your contacts. And then the last part of Chapter 3 talks about graphics. Again, not a lot of this stuff needs to be memorized, but it's nice to know that a little bit about graphics because it affects how you can use them. Graphics are created in different formats, and depending on how it's created, it has an impact on how you can use it. So bitmaps, for example, are pictures that are created with grids. So it's like colors are on a certain part of the grid, and depending on where it is, that's how it shows up on your screen. It's sort of like the old kind of cross stitch where you had that plastic that had the squares and you would use yarn and weave the yarn in, and depending on what color it was, you would get a picture at the end. That's sort of how a bitmap is created, and the reason that's important is because if you try to make a bitmap too big, you'll start to see the grid, and it won't be a smooth picture. It'll look like a whole bunch of little squares connected together. A vector graphic is what you get if you use a program like Adobe Illustrator. The pictures can be blown up pretty large because they're using vectors or mathematical equations to create the picture. It's complicated, so you don't really need to have the knowledge of how vector graphics are created, but just know that if you're going to be, for example, submitting a design to make a t-shirt, a lot of times the artists want to have the files as vector files because they get a better product at the end. Things to consider with pictures and on video as well is that the files are normally really large because it takes a lot amount of data to be able to store a picture. And so the format may have an impact. If the file is too big, for example, it's hard to send it as an attachment. the file is too small, the picture is going to have a bad quality. These are some of the kinds of graphic software that you can use. Microsoft doesn't have a whole lot of functionality, so when you do like Paint, Macs are generally a lot more advanced when it comes to graphics. So photo editing and drawing programs are a lot more user-friendly on a Mac than they are on a PC or a Windows computer. Most of the different kinds of products we buy now are designed with a computer. So computer-aided design software allows you to sketch and create models of things that you want to actually create in 3D. There's actually 3D modeling software and 3D modeling printers, which allow you to create a design on the computer, and then it'll print out for you a 3D model of whatever you created on your computer. So a lot of graphic designers are learning about these types of programs. Multimedia software is very similar to graphics software in terms of it requires a lot of space on your hard drive. It takes up a lot of processing speed. So if you're going to be doing a lot of graphic and video work, you probably need to have a pretty strong computer, a lot of memory, a lot of hard drive space. Macs are designed better for media, audio, video, and pictures. iMovie is an example of multimedia software. Windows has a Windows Movie Maker program that's not as powerful. And that's basically chapter 3. So you can download the slides. My notes are here at the bottom if you actually go into Laulima and download the slides, but I'll also make the video available for you.